Okay, I guess that should constitute to a quorum. Okay, so we have at the moment 27 participants for today's lecture. Okay, so good afternoon, HKIMO Secondary 3. I am Coach Ron, and I will be, yeah, got something? Okay, afternoon. Afternoon. We will be walking through our mock exam. We're going to be walking through our mock exam. What's in the mock exam? The mock exam should have been given to you right after you registered for this one. So it contains a good sample, okay? A good sample of what we are going to expect from our HKIMO. And I believe all of you had experience with this one already, but you had your heat round, you went through your heat rounds and you passed your heat rounds. So you do have, well, I believe is a good foundation of this one already. We are just gonna be viewing through what we know at present. Okay. So it's not much of a challenge. We all know what's gonna come up on this set. We're just gonna view things. Just a quick refresher about heat. For those who are not really friends of reviewing beforehand, and those who are fans of cramming, this is for you. And for some who may have forgotten a few things along the way, this is a good take for you as well. Okay. So yeah, again, welcome Secondary 3 to our session. Okay. Now, general instructions for today. Please be attentive and mute your microphones when not in use. It is an issue sometimes when somebody forgets to turn off their microphones. We do hear some sort of background noise sometimes, and as much as possible, we want to avoid that. But you're allowed to turn on your microphones if needed. If, per se, you want to speak, or you are called upon to speak, you may turn on your microphones. And third, please feel free to ask via chat or voice. So if you have a voice, you want to chat, you want to ask something, you may chat it via chat, but sometimes it's hard to chat it via chat, you know? So it's all right to chat it via voice. So just turn on your mic and ask your question. But please, if you're chatting via voice, please make sure nobody is speaking before you turn on your mic, just to make sure we're gonna have an ease of lecture. Okay. So I am Coach Ron from MOTL. I'll be with you for today. So time check, it's 11:27 Hong Kong Standard Time. Let's start our sets. Okay. So we have 5 sets for our mock. I'm sure you're all familiar. We have our logical thinking, our algebra, our number theory. We have our geometry and combinatorics. We'll start off with our logical thinking. Let's see if got a good answer here. Okay, logical thinking. Okay, I'll get a pen. I'll grab a pen and I'll write it on as we go through. Okay. Given that the first 2015 positive integers, so what are we talking about? 1 to 2015. Okay. Now, there are 305 prime numbers for the, okay. Among these 2015, we have 305 primes. For the first 2015 positive integers, how many numbers have more than or equal to 4 positive factors? Okay, interesting. Okay. Now, let's look at this one. No? Now, there are 2015 numbers here. And generally, all numbers should have factors. No? Is that always? Yeah. You have the identity property, which states that all numbers are factors of themselves. So what we can expect that these numbers have either 1 factor, 2 factors, 3 factors or more. No? The more composite the number is, the more factors it should have. No, there are numbers that have a lot of factors. Let's say 360. 360 has a lot of factors. That's a good example there. Some numbers have 4 factors. Some numbers have 5. Some numbers have 6. And we can carry on that one. Dot there. No? So, out of these 2015 are categorized into these. They're categorized into these. And how many do we want? We want only, okay? We want only 4 or more. So what does that mean? We don't want this. We don't want this. We don't want this. Okay? We don't want those. We don't want those. Okay? So question is, how do we do this one? So all numbers are categorized to have 1 or more factors, and we want 4 or more. So we just need to remove all factors here. No? So how many numbers have 1 factor? 1. The number 1 is only 1 factor. That's itself. How many numbers have 2 factors? Prime numbers. Prime numbers have an identity such that their factors is 1 and itself. So there's 305 primes. Okay? 305 times. Yeah. 3F, very good. We have a very good answer via chat here. 3 factors should be square of primes. What do you mean by square of primes? No, if you have a prime number, it should be a square of a prime. It should have 3 factors. 1, that prime number, and that prime number squared. Okay? So, let's try to deal with this one. How many primes, okay? Let's try to look at the closest square number close to 2015. So, I think the closest one should be 44 squared. No? 44 squared is the closest I can think of. That's closest to 2015. 44 times 44, that's 1936. Okay? So we are looking for the squares of our primes for, cubes by prime or product of the, that's a cut there, but we don't need a 4. Okay. 44 squared. So what we need is the prime numbers, the squares of primes from up to 43 squared. Okay. So we have 2 squared, 3 squared, 5 squared, and so on. Up to 43 squared, these are not gonna be included. Okay. These are not going to be included. So how many are these? 2 squared, 3 squared, 5 squared, 7 squared, 11 squared, that's 5. 13 squared, 17 squared, 19 squared, 23 squared, 29 squared, that's 10. 31 squared, 37 squared, 41 squared, 43 squared, that's 14. So we should have 14 here. Let me check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So you have 14 numbers here. So let's total that up. If we tally that one, we should have 320. So the numbers with 1 factor, 2 factors, 3 factors, there are 320 of them in total. Okay. So how many should theoretically have 4 or more? We just subtract 2015 minus 320. We should get 1695. That's it for number 1. Easily so. Okay. Next up. Peter goes west for 33 kilometers north for 24 kilometers, goes east for 17, and goes south for 12. How far is he now from the original position? Okay. Before I continue on, I would like to remind everybody that we are students from different nationalities from different parts of the world. So I understand that for some countries here, English may not be your first language. It may be a second language or a tertiary language for some. So if there are terms used in English here, or if I speak terms in English that may not be the translation in your local language books, please give me a heads up. Okay, maybe we'll talk about it if there are issues that are brought about by our language barriers. So I'll try my best to cater as many language barrier issues as possible. So feel free to ask it ever. Okay. Now we have a few directions. Now we have west, north, and east. So I'm gonna draw my compass here. I'm gonna draw a compass here. What's the purpose of that compass? That will indicate my direction. Okay, that will indicate my direction. Now, compasses are arbitrary, so there are some compass arrangements that are acceptable. You can swap north and south, and you can swap west and east. That's very acceptable. Okay, so it kind of depends on which direction you're looking at. So they're arbitrary. You can swap it up to a certain degree. So based on my picture here of a compass, not perfectly drawn, but I think that will serve its purpose. Okay. Now we go. Yeah, this is Peter here. Let's draw Peter. Okay, yeah, forgive my expertly drawn stickman. Who goes west for 33? He goes north for 24. I'm just following the compass images. And this might not be perfectly scaled, but okay. North and goes east for 17, and goes south for 12. Okay, 17 and 12. This should be what's Peter's path in general. So do we add everything? No. We're looking for displacement, or how far is he from his original position? Oh yeah, no, nice job there. It's 12 and 16. So we are calculating this one. Okay. So how long is this? This should be 12 here because that's 24 minus 12. And this length here should be 33 minus 17, so that should give us a 16. Okay. Now, if you, I'm gonna zoom into this one. This pathway here, 12 and 16. If you look at this one, if you notice that it's a right triangle. Is it a right triangle? Yeah. We are using only 90-degree increments when we travel north, south, east, west. So yeah, for sure we are gonna be having a 90-degree angle. Okay. So how do we solve this? But it's a hypotenuse. We're looking for this one, which is the hypotenuse. Let's just say C of a right triangle. And if you recall your Pythagorean theorem, C squared is equals to A squared plus B squared. Hence, we have C is equals to the square root of 12 squared plus 16 squared. Oops, sorry. That's 144 plus 246. So that's the square root of 400. So C should be equal to 20. He's only 20 units from where he was earlier. That should be your final answer. Yeah, nice. No, nice. 20. Yeah, nice job there. Oh, yeah. Very good. Very good. Anong tawag here? Very good output for everyone, from everyone. And if you're wondering why it's like I'm talking to thin air, there are actually students that are sending private messages. I have 3 students sending private messages at the moment. So yeah, if you want to have any comments and stuff, you can send it via private message, and or comments, questions, or queries, you can send it via private message or public message via chat. Either way works. Okay. This is a tricky one. This is a tricky one because we don't know what this number is. We know it's a 6-digit number. Times 4, it becomes a 6-digit number, but the order changes. That's an issue. Very big issue. So how do I fix this one? Okay, it has to do something with these two terms, EF and ABCD. ABCD, EF. EF, ABCD. Okay. Am I gonna declare them as 6 different variables? No. I'm gonna declare ABCD as 1 full variable. And I'm gonna display EF as 1 full variable. So let's just say, what's a good variable here? Let's just say this is X. And let's just say this is Y. So X is 4 digits. Is a 4-digit number. And Y is a 2-digit number. Let's just say it's like that. We're gonna declare it as so. Now, what am I gonna do next? Okay, it's but X has 2 numbers before it, so it's 100X. Why are we putting 100X? Because there are 2 place values before X, so we need to move X 2 place values. So we're gonna make it 100X. If it was just 1 place value over, I would say 10. If it was 3 place values over, I would say 1,000. For this case, I'm just gonna say 100. Okay, and I'm gonna put Y because Y is in the end, and I'm gonna multiply that by 4. Yeah, I have something. Ooh, have an amazing trick here. Well, right. Let's see. Oh yeah, very good answer there, Mr. Espino. And we're gonna do the other risk, equate that one, and the EF is 4 digits away. So we're gonna add 4 places there. So X, and we're gonna add 4 places. Wait a minute, I should have wrote that in the far right. Okay. So written that in the far right. X, and I'm gonna put 10,000. Why 10,000? It's 4 places from the, I don't know, 4 places. Diba? If you forgot how this works, let's recall our place values. That's, I think, a primary lesson or an elementary lesson for a lot of us, no? Place values. So when you have a place value, you multiply that by something with a lot of zeros there. Oh, sorry, I flipped it over. It should be a Y. The EF should be my Y. Plus my X. Okay. Now what I have to do is I have to simplify things. 400 X plus 4Y is equals to 10,000 Y plus X. And we need to simplify a lot of things. We get 399. We're moving all the X's to one side, moving all the Y's to one side, and we got 996. Okay. What we need to do now is I need to simplify this one. It's a large number, so I think I can divide this with, wait a bit. What number can I divide that by? 399. 7. Yeah, 7. 7's a good GCF here. I'm going to divide both sides by 7, and then I'm going to get 57. X. It's just simplifying, right? 1, 4, 2, 8, Y. Okay. What does that mean? Can I move this one further? I don't think I can simplify it any further. Oh, well, wait, we can simplify it further. Okay, we can simplify it further, but why am I ending here? I want my x to be a 4-digit number, and I want my y to be a 2-digit number. I can further simplify this by dividing by 3. But what do I get? If I divide it further by 3, I'd get something like a 3-digit number on the right side. I don't want that. And if I go upwards, like multiplying everything by 2, I get a 3-digit number on the top, and the 4-digit number, well, doesn't really satisfy the rules. 133. We could go with 133. Yeah. 133, should we divide them by 133? The issue there with dividing by 3, we have a good answer by one of our classmates. We have 133 x. Does that work? That can be simplifiable when we divide by 3. Yeah, that is correct. That is correct. But we need this condition here. You got a 3-digit and a 2-digit. So we have a, we have a 3 and a 4. That doesn't really work here. Doesn't really work. And we have, we'll try it to, it's kind of a trial and error thing. Huh? Trial and error thing. So it won't actually work like that. Okay. So we have this one, 57 and 1/4. Okay. So how do we deal with that one? Okay, how do we deal with that one? Let's swap the order. We can get x is equals to 142a, and y should be equal to 57. What should be our final answer here? E, F, A, B, C, D. That it should be yx, right? So that should be 57, 1428. Okay. We could have other combinations, but this won't work because the issue here is, it should be 2-digit and 4 digits. Okay. Next up. 30 problems in a math competition. Okay. 0 marks will be given for a blank answer. 5 marks for a correct answer. 0 marks will be given for a blank answer, a wrong answer. Okay. So find the minimum numbers of candidates that will have the same scores in this competition. Fairly easy. Let's deal with this one. Oh, sure. Okay, we have that one for okay. Okay. So let's go back to that one. Okay. Okay. I hope that no, that fixed your theory there. Okay, are we good? Are we good? Okay, nice. Next up, there are 30 problems in a math competition. The scores of each problem are allocated in the following ways: 5 marks for correct, 0 marks for a blank or a wrong answer. So, in summary, you get 5 points for correct answer and none if you don't get the correct answer. Okay. So, what are our scores for this one? Now, your score can be either from 0 to 150, right? If you get everything wrong, you get a 0. If you get everything right, you get a 150. Okay, if I get one answer correct, you get 5. If I get 2 answers correct, I get 10. You get 3 answers correct, I get 15, and so on. So how many possible options are there for the scores? We get 31. That's 0 correct, 0 right answers, 1 right answer, 2 right answers, 3 right answers, until we get 30 right answers. So those are our options. So I've seen a lot of people that get an issue with this one because they automatically assume that there are 30. Because there are 30 problems, there are 30 different scores. No, we can assume that you got none of them correct. So that's gonna be a 31. Yeah. Oh yes, we have someone here who says pigeonhole theorem. Okay. Applying the pigeonhole theorem, So we want 5 candidates to have the same, so it's 31 times 5 minus 1 because we want 5 of the same. And we have plus 1. Thanks for that, Mr. Espido. We have, yeah, 125. So 31 times 4 should give me 124 plus a 1. Yeah, that should give us a 125. Thank you for your outputs, guys. 125. Okay. Next up, the light is on. Amy presses the light button this one. Well, if I was to say bluntly, amazingly, Amy has a lot of energy to push these many buttons. So yeah, for theoretical purposes, let's just accept that one. Okay. Now it's on. Now it has to do something with odd or even. Now what we're gonna do today is it's just a different it's a concept of odds and evens. Odd and even. Why? If it's odd, let's use our logical analysis on this one. If it's odd, you're gonna need to click it. If you click it an odd number of times, it will be off. Diba? On, then off. Then another set there, that's gonna be off. But if we're gonna click it an even number of times, it's gonna be on. So do I need to solve for everything? No need to solve for everything. Well, you may, or I'm not forcing anyone to not solve this one. Not forcing anyone. It falls which would be better for you. Yeah. No? So yeah, we can rule out all the evens. Okay. So let's see. Okay. So for every 2 numbers, 1 plus 2, 2 plus 3 squared, that's gonna be odd, right? That's odd. It's gonna be odd. Because an odd number squared is odd, an even squared is even, so odd plus even is odd. So doing that from 1 to 32, so that should give us 16 odd. And 33 squared is odd. So 16 times odd plus odd. So that should be even. Well, I'll leave it to you. Maybe you guys have a lot of approaches for this one. Some people remove out all the even, that's good. Some people actually express that one in the formula. You have n plus 1, 2n plus 1. A lot of people. It kind of depends on the person. Well, this is the fun of math. No? So some will do this one and will guess like 33 times 34 times wait a bit, 67 over 2 over 6. Is it odd or even? Some people will do like that. Or you could do it like this. Okay. Now, if I do it like that, we got 6 messages here. Why is it odd on? Oh, okay. Question, why is it odd on? Now it's on at the moment. Okay? On at the moment. Okay? So if I press 1 time, it will be off, right? Press it again, it will be even. Press it Press it again. Sorry, not even. I meant on. It's on at the moment. It's there in the instruction. On. So 2 on, 3 times off, 4 times on. So from this we can assume. On. All odds will give us an off. All ons will give us an even. Okay. So it's actually a battle. Yeah, very good. OE. Yeah, OE. Okay. So it's just a battle of stuff like that one. Just a battle of stuff like that one. Okay. So our answer here should be even times odd, that's even. And even plus odd, is odd. So we know that it's going to be odd here. So we have odd. Okay. For some, you can do it like this. Is this odd or even? Oh, this is clearly odd. So it's off. Or you can try modulo on this one. Or you can have a lot of tricks there. Okay. So either way, as long as it gives you a definite answer of whether it's odd or even, yeah, it would be pretty much easier. On the solution manual given on the mock test, you can do modulo also. No, that's a good alternative. Yeah, well, actually kind of depends. No? Okay. May 2018 is Saturday. Which day of the week will May 12, 2028 be? Now, 365, we divide that by 7, all right? Diba? We're going to have a remainder of 1. I know, 65, sorry, 65. Because 364 is divisible by 7. 365 days over 7 will give us a remainder of 1. So what happens? Every normal year, it's gonna change 1 day. So I'll give you an example. Today is August 21. It's a Sunday. Next year, it will be a Monday. The year after that, August 21 will be another day. Okay. So how many years are we passing through from 2018 to 2028? 10 years. 10 years, no? So plus 10 days there, no? 2018 to 2028. But I'm gonna add a bit. I'm gonna add 3. Why am I adding 3 if it's just 2018 to 28? Because I need to consider what 2020, 2024, and 2028. These 3 years are called leap years, which have an extra 1 year. They don't do 365, they do 366. So plus 1 for each of them. So you have 13 in all. Yeah, no? 13 in all. Yeah, nice job with that one, guys, no? So it means it's 13 days from Saturday. Let's count that one. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, and that would be a Friday for that one. Oh, not much of an issue, right? Not much of an issue. Okay, next up. Okay, let's go on to our algebra. Oh, I hope you remember. The sum and product of the roots. I don't think we. Diba? The sum of its roots is sum alpha plus beta is equals to negative b over a or 7 over 1. Yeah, 7 over 1. Nice. The product of its roots, alpha, beta, it's just c over a or 9 over 1. Oh. Okay. So let's just remove the ones there. Let's be like that. And we do know for a fact that alpha squared beta, now this is factorable. Alpha squared beta plus alpha beta squared, that's factorable. That will give us alpha beta times alpha plus beta. Factorable. Completely factorable. Okay. So how much is this one? This is alpha beta is 9. Alpha plus beta is 7. So we get 9 times 7. Or, nice job, guys, 63. Oh, an easy one, no? Next up. Oh. Okay, let's see. Now, just to minimize the our possible issues, let's move all the x's on one side. Let's move on the all the y's on one side. So x squared minus 6x plus 5. Mostly the pi, y squared minus 4y. Now, as much as possible, it would be nice to turn them into squares. No? It would be nice to turn them to squares. So, x squared minus 6x, a good perfect square would be like 9, no? X squared plus 6x plus 9 is a perfect square. So I have a 5 here. So I'm just going to add 4. I want the perfect square. So I should have x squared, no? X squared minus 6x plus 9 is equals to y squared minus 4y. Oh, sorry, plus 4. Okay, and I'm going to do my completing the square here. This is a perfect square, luckily. No? X minus 3 squared, it's equals to y minus 2. Okay. We have a lot of answers here. A lot of people are saying xy is 6. I have 1. Yeah. 2 people says xy is 6. Xy is 6. Why is xy 6? Because x is 3, y is 2. Okay. Now, actually, one clarification for everybody. Yeah. One clarification for everybody. It's not just this one. Because what happens here? What happens here? If I do x is equals to 4, y is equals to 3, that will satisfy it. That will become 1 squared is equals to 1 squared. Okay. I could do a lot of things. I could do stuff like x is 11 and y is 10. And I'm not, I could do that one. I'm not gonna even deal with the negatives from that one. Okay. So are we gonna accept this one? No. Because xy is not limited to 6. You have a lot of solutions. You have a million. Actually, an infinite number of solutions. I could also go as crazy as go like x is equals to negative 2. And I could go y is negative 3. Right? I could go like that. I could go crazy like that. I could go negative 2 and I could go 7. It's not just x plus y is equals to 1 because this satisfies it as well. Food for thought. X minus is equals to negative 2 and y is equals to 7. That actually, that actually satisfies. Okay, that actually satisfies it. X is equals to 2, y is equals to 7. So what does that mean? We have an infinite value sets for x and y. And they didn't even say that y and x are equal, and that y and x have to be integers. For all we know, we could be dealing with decimals, we could deal with fractions, we could deal with irrationals, and we have a lot of answers. So how do we do that? How do we find xy? What's xy there? Xy is just not, I don't know, it's just not x is equals to y plus 1 because this satisfies it as well. Nah? What are we going to say here? Xy is everything. Because you have an infinite number of solutions there, probably for so. The concept of mathematics teaches us you can have everything. We can have everything from negative infinity to infinity covered here. In between infinity and negative infinity covered. So what does that mean? xy can be any real number we can think of. Okay, again, repeat that. xy can be any real number we can think of. Because we have a lot. Now, I'm really sure if you got a piece of paper, you can give me like 10 or more different solutions here. So sky's the limit for that one. So it's not just one number. It's like all different values are doable for that one. Okay? All values are doable for that one. Okay? So I hope that that cleared things up a bit. Okay? Next up. Simplify. The square root of 39 plus 12 square root of 3. Now, we're going to break this one here. Now, 39, I want to break it. How would I write that for the test papers? You could say, oh, wait a minute. Will you give mark to all those solutions? What do you mean by solution? Like, solution, this solution? Can you clarify what kind of solution do you mean? How can we write the answer onto the test paper? How do I write this one onto the test paper? You can say all real numbers. No, you can say all real numbers. That's pretty much you can deal with that one. No, you can deal with that one. All real numbers. You can write the text there depending on what's that translation on your language. That's my shortest solution for number 9. Ooh, you have a shortest solution for number 9. Wait a minute. Okay. Okay, number 9. Let's try to break this down. Let's break this down now. Let's break this down. How do we break this one down? We have a very interesting one from Mr. Espino. I gotta give him credit for this one. This is a good one. What he did was he recreated this one into okay. 39 plus 2. What did he do? Why does it become 2 square root of something? He put down the 6 inside. So 36 times 3, it's 108. Very interesting trick here. I really admire this trick. It's a fun one. Okay. So how do we break something like this? We can break it easily. But if you notice, if you have something like A plus square root of B, it's gonna look like, if you're gonna square it, what's it gonna look like? A squared plus 2ab, 2 ab plus b. Right? It could be like that. So if you wanted to express this one or this one at first, if you express this one at the start lang, if you express this one, you can end up with something like, if you were gonna form it this way, you can form 6 squared, right? Plus, just follow this one, express it into something like this, okay? You can express it as 2 times 6 times square root of 3 plus square root of 3 squared, right? You can form it like that. Just follow this form here. So therefore, we got here, if you follow this one, we got an A of 6. Diba? Square root of B. Forgot that one. And B is square root of 2. Right? I know, B is 3, sorry. B is 3. So our final answer would be 6 plus square root of 3. We just have to look for a way to express it like this. And we have a fun one from Mr. Espino here. How did you do that one? Okay, we can break out this one. We broke this one into 6 plus square root of 36. 3, sorry, 3 plus square root of 36 from this form. If you're using Mr. Espino's for the same, you can form it like this. Either way, it will give you 6 square root of 3. Inspiration from the quadratic. Oh, yeah. There is a method like that. I forgot the name of that. I think it's least residue quadratic. I forgot the name. There is a technique like that. Good job for finding that one. That's one of the less talked about things. Okay, you have number 10. Okay, now what do we know? Now it's greater than 0. Okay, when it's greater than 0. Okay, now what do we know if it's greater than 0? Okay, if it's greater than 0, hence its discriminant is less than 0. Ooh, okay. Sure. Ta-dang. Okay, nice. Okay, going back to number 10. Its discriminant has to be less than 0. What's discriminant again? B squared minus 4ac. That's the discriminant. So A here is 4. B here should be K. And C is 2 to 5. Okay. Let's express this discriminant. So therefore we have K squared minus 4 times 4 times 2 to 5 is less than 0. Okay? So you have K squared minus 3,600 is less than 0. Okay? We have alpha. We can factor out this one. Right? It's a difference of 2 squares. So we can go like or if you don't like it, you could go with let's do both. Let's do both for now. It depends on how you guys would like to do this one. So you could cut it into 2. So we could do K plus 60 and K minus 60. That's a difference of 2 squares there. Oh, sorry. If you equate that to 0, therefore our range of K. What's a range of K? No, sorry. I forgot less than. The range of K should be one of them should be positive and one of them should be negative for it to become negative or less than 0. So K should be somewhere in between negative 60 to 60. Okay. Negative 60 to 60. Sorry. Now, if you go on the other one, you could actually go with K is less K squared is less than 3,600. Okay. So less than 60, no, up to 60. But you can do the negatives also. You can do 60 also too. A negative 60 also to 60. Either way. Sir, why is it 0 to 60? Diba? Why is in negatives included? Because it's a square. Well, we could do the positives as well. If what we could do to the positives for a K squared, we could do to the negatives. So for either method, you get negative 60. Our minimum integral value should be, we can't go to 60 because it's strictly less than. So greater than 60, so it's negative 59. Ta-da! Okay. Okay, next step. Oh, how do we do this one? If you remember, we need to get the vertex form. I don't know if you're for other nationalities. I'm really sure it's vertex form for the Philippines, but I'm not really sure for some nationalities on what term they use. I think it's still vertex form. For some they use some they use graphing form. It actually depends. We use the term, the local term for us is vertex form, so it may be graphing for whatever form there. Just to explain, it kind of looks like this one. I'm not really sure on what you guys use. Okay. Value will be, oh yeah. I can work like that. One person says negative b over 2a, or he got the, I know, he got the negative b over 2a is, I'm gonna write that as another equation here. Okay, we'll do it that way in a bit. First off, let's do it like this. Change it into vertex form. Now, what do you mean by changing it into vertex form? It's a square number plus k. Okay, it's a square number plus k, so it's negative x squared plus 12x. What do I need to partner out with 12x? So it will become a perfect square. Well, I have, no, this is all actually a perfect square already, right? So I have negative x squared minus 12x plus 36, or I could get easily so negative x minus 6 squared plus 0. I'm going to put a plus 0 here just to mark our answer here now. What's this 0 represent? 0 represents our maximum for this case. No? Sometimes when we solve, there should be a residue of something if it's not a perfect square. But luckily, there was no residue because it is a perfect square. So how do we do it in this case? Well, it should be the residue of the perfect square. Why? Because this is 0 and up. Diba? When you have, why do we utilize it as a square number? Because a square number is 0 and up. So a negative square number means this is negative 1 and up. 0 below. If it's a positive, 0 above. So 0 below, the highest there is 0 plus 0. That will give us a 0. You have another alternative here, Mr. Janelle. He got negative b over 2a. Okay, let's do that one. Negative 12. All right. Over 2 and negative 2. That will give us 6. What's this representation of these 6 that negative Mr. Janelle got for us? Now, this actually represents, this is, I forgot that, this is the coefficient of the h. No? This is the h value. You just have to substitute that one. If you got this through this way, to get the minimum. If you substitute that one, you're going to get the 0. So still, our maximum, is still going to be a 0. Okay. Now, next up. Find the value r in the system of equations. Well, don't know about you guys, but when you went to, I think, for most secondary 3 is around 9th grade for some, depending on which level are you, depending on your school curriculum and your country's curriculum. I do know one thing, that you guys are familiar with doing systems of equations. And what you do there is, we usually know how to get 2 equations and 2 unknowns, 3 equations, 2 unknowns. And that's technically a bit hard for us already when we're dealing with 3 equations, 3 unknowns, right? So what we have here is 5 equations, 5 unknowns. Let's do this one. By normal means, that would take a while to solve. By normal means. Okay? But if you look at this one, there's a good pattern. There is a good pattern here. Okay? There is a good pattern. Okay? There is a good pattern. What's a good pattern there? Okay? What's a good pattern? Okay? If I add this one, now look at that. Note that all of them, they have coefficient 1s and a 3. 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 let's try to add that one. There's a good pattern. You'll see, you'll appreciate the pattern when it comes. 7R plus 7S plus 7T plus 7U plus 7B. That looks pretty, beautiful. That looks nice. That looks beautiful. And if I'm gonna add all the numbers, that's 35. Now, they're all divisible by 7, so I can simplify that as R plus S plus T plus U plus V should be equal to 7, right? We have a good form here. Now, we are gonna look for R, so I'm gonna need to utilize not 7, but rather 5. My bad. 35 divided by 7 is 5. Sorry, thanks for that one. Okay. Now, we do know that 3R plus S plus T plus U plus V is equal to 5. I'm going to subtract this equation from that. Okay. And why the last equation? Because we're looking for R. It has the multiple R. It has the multiple R's. So, we're going to get 2R is equal to 0, right? Subtract every letter there. All the letters get canceled. 3R minus R becomes a 2R. 5 minus 5 becomes a 0. So 2R is equal to 0. What? So R should be also a 0 for that method. Right? So not much of a trouble. Okay. Now, how many simplified fractions with denominator 1001 are there? Now, what is the requirement if you are a simplified fraction in the denominator for 1000? What's the requirement for that to happen? You have to be coprime. What's the other term for coprime? Coprime, if it's not on your, it's not on your local dialect. Coprime means GCF of 1. No, 2 numbers are coprime if they have a GCF of 1 or an HCF, depending on which you use in your school. Okay. Oh yeah, nice. So let's do this one. Okay. Now I know that 1001. This should be 7 times 11 times 13, right? Okay. Now, how do I know how many numbers are coprime with 1001? Okay. Now let's see. Let's put 1001. Now, if you notice, every 7 numbers, think about this for a bit. Every 7 numbers, every 7 consecutive numbers, one of them is divisible by 7. Right? I repeat that statement. For 7 consecutive numbers, one of them is divisible by 7. What does that mean? For every 7 consecutive numbers, 6 are not divisible by 7. Right? So we want that 6 because that we don't want it to be divisible by 7. Because 1001 is divisible by 7. So what fraction of numbers are not divisible by 7? 1 out of 7 is divisible by 7. So 6 out of 7 is not divisible by 7. Right? Likewise, out of every 11 numbers, one of them is divisible by 11. That means 10 out of any 11 consecutive numbers are not divisible by 11. Out of 13, 12, out of 13 consecutive numbers, 1 is divisible by 13. So that would mean 12 out of every 13 are not divisible by 13. Okay. So we just have to multiply that one. How much is that when we multiply that one? 720. Okay. So that should be our final answer for that one. Okay. Hope that went enough. Oh. Now, this one is not really a good friend of ours. Okay, this one is not really a good friend of ours. So let's try. Okay, let's try to deal with this as best as we can. Okay, we're gonna do Chinese remainder here. Yeah, Chinese remainder. So, okay, let's do a Chinese remainder here. So let's express maybe 8 mod 3 as 8a. No. 13a. This is gonna take a while, plus 8. Okay, and we're gonna plug that in the second equation here. So 13a plus 8 is equals to 6 mod 7. Okay, so I'm gonna transpose the 8, so I'm gonna get negative 2 mod 7, so I'm gonna get 13a is equals to negative 2 or 5 mod 7. Oh, sorry. 7. My bad. Let me remove that one. Okay. Now I'm gonna keep adding 7 to 5 such that it will be divisible by 13. Let's keep on adding 7 to 5 such that it will be divisible by 13. So let's have 5 plus 7, 12. That's not divisible by 13. Plus another 7, 19, not divisible. Okay, 26. That would be good. 13a is equals to 2 mod 7. I don't know, a, sorry. 13a is equals to 26 mod 7. Sorry, my bad. Let's remove that one. 13a is equals to 26 mod 7. So a should be 2 mod 7. Yeah, you check if I did everything right. 6, 7, 13, 8. Yeah. So let me just recheck if I did everything right. 13 minus 8, 5. Yeah. Did everything right. Okay. Gonna plug that back. So a is equals to 7b plus 2. Plug that in the early equation. We have 7b plus 2 times 13 plus 8. Okay. So you have 13 times 7, that's 91. 13 times 2 plus my 8, that should be 34. Okay. Now let's plug that into our next equation. I'll put that on the left. 91b plus 34 is equals to 4 mod 5. Okay, 4 mod 5. 4 mod 5. Okay, now I'm gonna transpose that on the other side. That's gonna be 91b is gonna be negative 30 mod 5 or 0 mod 5. No, is 0 mod 5. Okay, so let's do divide both sides by 91. So b is just 0 mod 5. Now, someone is asking, why was I annoyingly doing it from down to up when I could just did the 5 below down? And why did I start from the bottom? Well, it's a personal preference for me. Now, I think it's a good tip for you guys. When you do this one, you need to start from the harder ones first. Note that I left 4 mod 5 for last because it's very easy to solve. Right? Because the more on you deal with modules, the larger the numbers becomes, and you're gonna leave the larger numbers in the end. That's gonna be overkill. So what I like to do is I like to do the bigger numbers first and end them on the last numbers. It tends to be easy most of the time. No, it tends to be easy finding the modulus of each. Okay, so b is equals to 5c plus 0. Plug that in back on our original equation. 91b. No, sorry. Plugging that into our original equation, we have 91. 5c plus 0. Plus 34. Okay. And when I simplify that one, that will become 108. I don't know. 8. Oh yeah, 45. 455. Sorry. 455. C plus 34 or 34 mod 455. That should be our final answer. 34 mod 455. So what are numbers that actually form 34 mod 5? What's the smallest? 34. This one. 34. So that should be that form. That form. Next up. If x is less than 0 and x is odd and x is 17 mod 29, find the minimum value of x, right? If you remember what we did earlier, the same method as we did earlier, you're allowed, if you look at this number here, you're allowed to add or subtract 29 there an infinite number of times or any of your choice, and it will be the same equation. So it's negative, right? It's less than 0. So I'm going to decide to subtract 29 there because I want it to be negative. So 17 minus 29, that'll give me 17 minus 29. I'm dealing with negative 12. Mod 29. Is that my final answer? Not yet. It has to be odd. Okay. Do it again. Minus 41 mod 29. No? So you have negative 1, negative 41 mod 29. So is that odd? Yeah, it's odd. And that's the smallest we can go. We can go more, you can go lower, but we want the maximum. So we're gonna stick at negative 41. Okay. Next up, x and y are positive primes which satisfy this one. Okay. Okay. So I'm just gonna factor out this one. I feel like factoring it out. X plus 3y. And x minus 3y is equals to 40. Okay. Now I'm gonna try different factors of 40 and I'm gonna equate it to, let's just say 40 and 1. Okay, let's just say 40 and 1. Okay, you can do 20 and 2. You guys could try 8 and 5 or what you guys, it's more or less a trial and error at this point. No? Let's try 40 and 1. X plus 3y is equals to 40. X minus 3y is 1. Yeah, this will give me an x of 41 over 2. No, 41 over 2. And I'm not going to continue on solving the y because it says that x and y are positive primes. Nope. 40 and 1 is not a good solution. Let's do 20 and 2. No, 20 and 2. X plus 3y. Now we're just going to take out the factors of 40 is equals to 20. X minus 3y is equal to 2. Is equal to 2. Okay, we would get from this one, adding up, that we would get x is 11. Okay, x is 11. Y would be 3. Okay, y would be 3. Okay, so we can have that one. We could have that one. No? Also, we could have, let's try another one. X plus 3y is equals 10. X minus 3y is equals to 4. We could have that one. Okay. So if that were the case, if it was like this, wait a bit. We would have x is equals to 7 and y is equals to 1. Sorry. So you have two sets of integer equations. X is equals to 11 and y is equals to 3. X is equals to 7, y is equals to 1. Are there more? You can try to find, look for more if you want. But as far as I know, these are the only solutions are gonna, but you can try the rest, you know. You can try 5 and 8. You could try the rest. Okay, you could try the rest. Okay. So what are our answers? X minus y here will give us an 8. Okay. X minus y here will give me theoretically a 6. Oh, wait a bit. This is not the, oh, wait a bit. This is not acceptable pala. My bad. It says primes. Right? It says primes. So I'm not going to accept this one because this is not a prime. 1 is not a prime. So I'm going to only accept 11 and 3. So that should give us 8. Okay. Okay. Next up. It's known that x is rational. X is greater than 0. It's a rational number, and x is square root of 4, square root of 4, square root of 4, square root of 4. Now, it is very easy because if you look at this one, this should be x, right? Square root of 4, square root of 4, square root of 4. This part is square root of 4, square root of 4, square root of 4 continuously. Right? This is square root of 4, square root of 4, square root of 4. Is it 1? I think it's more than 1. Okay. It's square root of 4, square root of 4, square root of 4, square root of 4. So this part is x also. So I can go with, I'm gonna substitute x inside of itself. Substitute x inside of itself. Are you sure with 1? I'm not really sure with 1. Ah, yeah, there's a 4. There's a 4. Square root of 4 x. Okay. Square root of 4. I'm gonna plug it here after one pattern is done. Okay. So x is equals to square root of 4x. I'm gonna square both sides. X squared is equals to 4x. So x squared minus 4x is equals to 0. So I get x and x minus 4. So I could have, it's either of x can be 0 or x can be equal to 4. So it says x is greater than 0. No? So yeah, x should be 4. Well, obviously we can accept 0 there because we know that this is not 0, right? You know that that there's a value for that one. So it's not 0, but rather 4. Okay. Next up, a 4-digit number has 3 positive factors. Very interesting. 3 positive factors. Now, I think Mr. Espino mentioned this a while back. I think it was number 1 or number 2. I think it was number 1. 3 positive factors is a square of a prime. Okay. Square of a prime. So let's look for the smallest 4-digit number. I'm gonna take a calculator. I'm just gonna pick out a number here from my trusty calculator. Let's see. 31 times 31, that's 961. 37 times 37, that should be 169. (31 times 31, that's 961. So I think undeniably we have one that's better than the other. No? I think we have that one. So either prime squared, so 31 squared, or 37 squared. I'm not gonna go 31, that's a 3-digit. 4 digits should be 1369. So that should be our final answer. Okay, that's easy. That is easy so far. Okay. Next up. Okay. Okay. Now, on to geometry. Hope you are. I left for a bit. What is the answer in number 17? I'm gonna catch you up for 17. Yeah, that is 4. 17 is supposed to be 4. Yeah, that's supposed to be 4 there. The solution is like there, up there. Okay. So next up. Okay. The next up is this one, geometry. So find the area enclosed. I think everyone is familiar with the Cartesian coordinates. So I'm going to draw my plane here. Back. Okay. Not really a straight plane. Gotta forgive me with this one. Not really a perfect one. So, yeah. I ask for your understanding. Not a perfect one. Okay. Now, how do we deal with this one? Well, it's enclosed by 3 sides: x-axis, y-axis. X-axis is a line. Y-axis is a line. And this is a line as well. So it's enclosed by 3 lines. So what do we know? It is a triangle. Right? It's enclosed by 3 lines. Okay. Triangle. Now, what do we do next? We know that x plus y is equals to 1. I think you guys are familiar now with your plotting of lines. It should look like this. Okay. So this is the line where it touches the y. This is the line where it touches the x. And that should be a right. That should form a right triangle here. Okay. Let's try to handle this one here. Okay. What do we have? At the moment? We have, it's a right triangle, luckily for us, because it's perpendicular. The Cartesian coordinate plane is a perpendicular, so we have right triangles. We can just simply use 1/2 base times height. Okay. Now, we just need to know this one and that one. Okay. This point here is the intersection between the y-axis and the x-axis in this line. This point is the intersection between the y-axis and that line. So what we are looking for is the x and y coordinates of that one. So we are looking for the intercepts. Okay. Now intercepts, when y is equals to 0, we got x is equals to -11. And if we get x is equals to 0, we're going to get y is equals to -11. So what are the coordinates? Negative 11, negative 11 there. So 1/2 base times height, 1/2 11 times 11. That's 1/2. Are we doing negative? Do I put negative inside there? No, don't do that. We're talking about displacements. We're talking about positive distances. You can't have a negative length. Well, those exist theoretically, but in terms of area, we're not going to deal with that right now. Okay, so that's 1/21 over 2. Okay, next up. Find the maximum value of sine. Now, what's the maximum value of sine? Sine, it was 1. Diba? I think you know that property. I can just say 2x is equal to theta. But this is a known property. Anything that's signed is equal. It's no, sorry, 1 to. I should say negative 1 to 1. My bad. Anything that's signed is in between negative 1 to 1. So you can have 2x as theta. So still, it's still a sign 2x. Although what you may like to, you can turn it into 3x, 4x, 5x is x, 6x over 7, something like that. But it's still expressible as theta, and it's still a sign. So it's still going to be object to the ranges between negative 1 and 1. So the maximum is 1. That's a fact. So this is an identity of sine. Oh, okay. Next one. Okay. We have 2 lines. Okay. We have 2 lines. Again, I'm going to draw my Cartesian plane. Okay. Now, let's draw these lines. Wait a bit. Let me give me a moment to think of what these lines look like. Yeah. Positive y and a negative x. Like that. Something like that. And this one has a positive x and a negative y. Okay, so something like that. Just imagine they may be something like that per se. Okay, not really sure. Now they intersect at some point G. So we're just gonna look for GO. Okay. Now what we do want to know is when these 2 lines will intersect. When will they intersect? Well, the intersection, simply put, is the system, the solution, the system of those 2 lines. So we have 3x minus 4y is equals to negative 14. And you have 5x minus 2y is equals to 14. So there are a lot of ways to do this. You may be a fan of substitution. You may be a fan of elimination. Either one is good, but I'm going to do elimination for this case. So I'm going to go 10x minus 4y is equals to 28. Right? I'm just going to do elimination. It kind of depends what you like to do. Some prefer to do substitution methods on this one. So negative 3x plus 4y. Sorry. Is equals to 14. So we get 42. Okay, so we get 7x is equal to 42. And then we get x is equals to 6. Okay. So if x is equals to 6, what does that say about y? Y is equal to 8. Diba? How do we get y is equals to 8? Just substitute x is 6 there and get the value of y to any equation. Okay. So what are we talking about? It's in O is in the origin, 0, 0. And we have a point at 6, 8. Right? How do we find the slope of that one? That's just rise over run, y over x. No? Delta y, delta x. Or for some, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's 8 minus 0. Six minus 0. That should give you 4 over 3. That should be your final answer, 4 over 3. Okay, 4 over 3 for that one. Or 1 and 1/3, either or, no? 4 over 3, 1 and 1/3, all of them are acceptable. Okay. Now, ABC, then triangle with side length 10, 10, and 12. Okay. So ABC is a triangle with side. Let's draw that one. Let's draw that one. Not really a perfect. Ten, 10, 12. Okay. Now, and what I'm gonna do is, I'm gonna inscribe the radius of the circle which inscribes. So I'm gonna put this. Okay. The radius of a circle. I'm just gonna put this here. I'm gonna put this in a circle. Okay. Not really perfect, but I hope you guys get the gist there. Okay. Okay. I'm gonna do that again. It really, the image really sucks. Okay. I'm gonna do it again. Let's just say it's in a circle like that. Not perfectly built, but I guess that doesn't serve us. better. Okay. Now, how do we do this one here? Okay. How do we do this one here? First off, we are gonna get this line here. Okay. First off, we are gonna get that line there. Okay. Why are we gonna get that line? We're gonna see in a bit. Now, how are we gonna get this out? This is 6. This is 10. So if we do our Pythagorean theorem, let's name this x. So x is equals to square root of 10 squared minus 6 squared. So x should be like an 8. Okay. Now let's find the radius. Okay. Now the radius. Okay, the radius should just be r squared is equals to, you have this 8, right? It's how this 8. Okay, you have this 8. And that's minus 8 minus r squared plus 6 squared. Okay. You just need to handle that one to get your 8. Okay, just need to handle that one to get your 8 there. Okay, that's the radius. It's here. Right, it's like that. It's like that. This is your r. You know, r squared is equals to 6 squared plus this line is how much? How long is this? 8 minus r. This is a radius. We can draw a radius into this imaginary point. Okay, can make a radius in our imaginary point there. Let's try to simplify. Luckily, okay, we're gonna get this should be equal to, well, the r squared will cancel out. No, we're gonna get 16r is equals to 800. I'm really sure okay, and we're gonna get, no, sorry, 100. So r should be equal to, give me a solution for number 20. Yeah, well, I'll go back to that one after this one. 100 over 16, that's 50 over 8, or 25 over 4. 25 over. Okay. So yeah, let's number 8 at 20. 20 was this one. No? The range of the sign value, always of any sign value, is in between -1 and 1. So 2x is no exception to that one. So even if you have a 3x, a 4x, a 5x, a half x there, it should be in the boundary of -1 to 1 always. Okay? So its maximum is 1 and its minimum is 1. Okay, how about cosine? Just for the fact of it. Cosine. Cosine also has a boundary on that one. Okay? Fun fact of both. Okay, fun fact of both. And always know, how do we get the cosine? Oh yeah. If you have a sine and cosine, just an additional lesson for everybody. Cosine squared theta plus sine squared theta. You can have both sine and cosine that are equal to 1, and they should have to adhere to this rule also. Okay. Just a fun fact for everybody. The basics of our sines and cosines. Okay. Got that one, 25 over 4. Next up. Okay. Okay. Let's draw this triangle first. We have our points. So we just need to draw this triangle first. Right? Just need to draw this triangle. Cartesian plane. Not straight again. I apologize. X is 1, y is 0. X is 2, y is 1. And we have x is 0, y is 7. X is 0, y is 7. Like that. So my triangle should theoretically look like that. Okay. Now let's solve for the sides of this one. Okay. Let's solve for the side of this one. This side here should be, that's 7. That's wait a bit. That's I'll write this out. I won't get confused. So side A, that side should be the square root of 7 minus 1 squared plus should minus 6, wait a bit, 0, 0. Oh, wait a bit. 7, joke, kidding. My bad, 0, 7. 0, 7. Thought something was up. 0, 7 minus 0, 7 minus 0. And 1 minus 0 squared. That would give me, this is the square root of 50. If I'm going to do the same on the other sides, I'd get square root of 40 for this side. And I'm going to get square root of 4 on this side. That's, yeah. Okay. Square root of 4. So I have 3 sides. Okay. I have 3 sides. Now, let's go on to our, now we have our 3 sides. Let's go on to our law of cosines, right? Cosine. Okay. Cos C. Wait a bit. C squared is equals to A squared plus B squared minus 2AB cosine C. Right? If you remember your law of cosines. And which point do we want? Oh, wait a bit. This is A. This is B. And this is C. So you want the this angle here. Okay. We want this angle here. Opposite it is 40. So we should get 40. 40? 40 should be our C because we want the opposite of A. Right? It is equals to 50 plus 4 minus 2 square root of square root of a square root of 50 square root of 4 cosine c. And if I simplify that, I'll only get cosine c, diba? It's 54. And simplify with that one, cosine and okay. Cosine c should be 3/5. Okay, that's that for that one. Okay, that's that for that one. I know square root of 2. Sorry, I thought it's square root of 2. Okay. And 2. Okay, so we get cosine c is 3/5. Next up. Earlier we did sine law. Now we're gonna do cosine law. Okay, let's draw ABC. So it should be obtuse for a bit, no? Should be like this one. Similar to this one. This is A, B, C. Okay. And AB is 3 square root of 2. This side here is 105 degrees. This side here is 30 degrees. Then it should follow that the remaining side is 45 degrees. Okay. So how do we do this one? Okay. How do we do this one? Let's try to. What are we looking for? We're looking for BC, this one. Okay. So we have 3 square root of 2. What's the opposite side? Opposite angle? 45. Is equals to what we're looking for? BC over, this is sine law, sine law over sine 30. How much is sine 30? This is a half, no? Sine 45, that's square root of 2 over 2. If you're not familiar with your identities, what do you mean by, I mean the proper, the values of the main sines and cosines, the multiples of 30 and 45, please view into that one, right? So it's 3 square root of 2 is equals to square root of 2 over 2. So I'm gonna cancel out that one. So I have BC over 1/2. Okay. So how much do I get for BC? A bit of simplification will give me BC is equals to 3. Aha, I got that one pretty easily. 25. Oh yeah. Off to combi. This is our last and probably depending on which you prefer, maybe the hardest or the easiest. It kind of depends. Okay. Oh, another systems of equations, right? Let's say apple is an A, a watermelon is an M. Okay. So 5A plus 3M. Okay. 3M is 1950. Okay. And what do we have? 3A plus 4M is 2050. Okay. So systems of equations like we did earlier. Okay. We're gonna do a systems of equations like how we did it earlier. Now, how do we how do 5, 3, 3, 4? What's a good approach here? Wait a bit, huh? I know we're supposed to multiply it there. But how do we make it a bit easy? Okay. I got a thing. Okay. I'm going to subtract those two. So 2 apples. This is a short method because why am I doing this one? Why am I not multiplying them like substitution method? I was thinking like, okay, let's do an alternative of substitution method. Negative. Okay. Negative 100. Okay. Now I'm going to subtract that. I'm going to double that for a minus 2m is equals to minus 200. Oh no, multiply that by 3. Sorry, my bad. Multiply that by 3, I guess. I'm going to get 6a minus 3m is equal to negative 300. Okay. Now add it to this one, I'm going to get 11a is equals to 160. So a should be 150. From there, I could play through. How do I want to play this one? 450. I could go with 450, substitute it here. So 4m is equals to 1/6. So m should be equal to 400. Okay. So you could do it like that. Okay. You do it like, hey, yeah. No need for that one, pala. I'm just looking for 1 apple. But yeah, it would follow it. It's like that. Okay, it would follow it like that. Okay. So a should be 150 here. No, you can do it like that. Pwede. Next up. There are 10 boys and 8 girls in the class. Choose a total of 3 boys and 3 girls to form a discussion group. How many ways are there in total? Okay. Out of 10 boys, we are gonna pick 3. And out of 8 girls, we're gonna pick 3. What's this? It's a combination, right? It's a combination. How do we do a combination? 10 factorial, 7 factorial, 3 factorial. That's for the boys. How much is that? 10 times 9 times 8 over 6. 10 times 9 times 8 over 6 has 120 for the boys. How about for the girls? How many ways are there to arrange the girls? 8 factorial. 5 factorial, 3 factorial. Okay. So 8 times 7 times 6 divided by 6, that's 56 ways for the girls. Okay. So 120 ways for the boys, and for the girls, it's 56. So our total should be 120. Multiply that for the number of combinations for each, we should get 6,720. Ta-da! Okay. Next one. A spare 6-sided die is thrown 3 times. Prime the probability that the sum of numbers is obtained is 4. Now for a dice, you can only have 1 to 6, right? 1 to 6. So when you're throwing 3 dice, how many ways are there? 6 times 6 times 6. 216 different outcomes. And out of those 216 different outcomes, how many do we want? We want either 1, 1, 2, 1, 2, 1, or 2, 1, 1. Do we have any more? I don't think we have any more. No? Out of all 216, because it's 6 times 6 times 6, we want 3 of them. So we want 3 over 216. Okay, 216. That will give us an answer of 1 over 72. Okay, now we got an answer. We just got everything, 216 different possibilities, and we know that we only have 3 cases that we want. This is fairly easy to list. For mga harder numbers, it would be a bit complicated, but luckily for us, 4 is rather small, so we have 3 options. 3 over 216 or 1 over 72. Okay. 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 Let's draw our Venn diagram. Okay. Let's draw our Venn diagram. We have this one. And this, oh, I need to make my circle bigger. Need a big circle here, another big circle here, and a smaller circle here, a bigger circle here, and a small circle outside. Why? Why? What's this? What's this? What's this? What's this, huh? What's this for? Okay. Now, let's say this is Chinese, this is English, and this is math. Okay. So why am I making 3 diagrams? Because a Venn diagram will easily show us how many passed both, how many passed one, how many passed like all 3. And let's put this one here as the fail people. Why are they outside? Because they didn't pass. They're not part of that Venn diagram. Okay. Now, okay. There are 40 in the whole circle. There are 38 here. And there are 37 here. Okay. 36 students passed both Chinese and English. Chinese and English gives us a 36. 34 English and math. And 32 passed all 3 subjects. 33 here. And 32. Now working from the top, we only have 4 who passed strictly English and Chinese. We have 2 who strictly passed English and math, and we have 1 who strictly passed here. Okay, so 1 plus 32 plus 4, that's 37, right? Minus 40 minus 37, that should be a 3. So 32 plus 4 plus 2, that would be a 34. No, 38. That's a 0 here. Nobody strictly passed English. No, 32, 4, yeah, 38. And this one here, it's 32 plus 1 plus 2. 32 plus 1 plus 2, that's 35. And you have a 37 here, 32. Let's add all these numbers. 3 plus 4 plus 0. Okay. There are 3 who passed Chinese only, 0 who passed English only, and 2 who passed math only. 2 who passed English and math, but not Chinese. 4 who passed Chinese and English, but not math. And 1 who passed math and Chinese, but not English. That should be our total value. Okay, let's add everything there. Let's add everything. We have 3 plus 4 plus 0 plus 32 plus 1 plus 2 plus 2. That should be 44. So how many are in the population here in total? There should be 44. So ergo, how out of 45 students, how many did not pass anything? There's 1. I kind of feel sad.
No. I suddenly kind of feel so sad for that last student. He didn't pass any single one. He's alone. Anyways, it's nice. It's a nice title for a movie. Okay, that should be that one. No, so I work backwards. I got 32, and I remove each remaining to get each specific part of the diagram, and I got the total. And how many are not in the total? That's the remaining one there. Okay. Okay, inside a 52. Okay, 2 cards are chosen. Sum is 18. Okay. So there are two ways for this one. King and 5. Queen and 6. Jack and 7. Okay. And 10 and 8. Okay, and 9 and 9. Okay. That's our possibility here. Now, what are we gonna put on the denominator? 52 times 51. 52 options for the first draw, 51 options for the second draw. Okay. What am I gonna do next? How many ways are there to draw a king and then a 5? There are 4 kings and there are 4 5s, right? Why are they 4 each? There's a king of diamonds, a king of hearts, queen of clubs, and a queen of spades, and a king of spades. Oh, 4. So you have the heart, but there are 4 options: the heart, the diamond. I hope you guys are fans of your poker games now, and the club. So there's 4 of each. So we have 4 times 4 times 2. Why am I multiplying 2? Because I can flip it over. 5 and king. Okay. So the same event for the other one. 4 times 4 times 2. And then that's gonna apply to this one. 4 times 4 times 2 also. And then 4 times 4 times 2 also. But this one is just 4 times 3. Because there are 4 9s, and if you draw 1 9, you're gonna be left with 3 9s there. Okay. So we're just gonna multiply this one. Okay. We're just gonna multiply this one here. Okay. So let's try to do that one. Okay. Let's try to do that one. 2, 4, 8. Oh, wait a bit. Let's multiply that. 60. Let's have 32 times 4 plus 12. That would be 140. That's the total of everything. 140. Okay. How can I simplify this? Okay. 70. 26. Oh, I should have done it twice. 35 over 13. Okay. So can I simplify more? Yeah, this is 17 times 3. No, nothing more. So I have 35 . 35 over 600 and 663. Okay, last number. This is easy. This is easy. No? So how many banknotes does he have? Let's say this is, I think this is 10 and 20. I think they had an issue with this one, 10 and 20. Okay. So we have A banknote for 10 and B banknote for 20. So you have A plus B is equals to 39. And 10A plus 20B is equals to 520. We are just looking for B, right? Okay. So I'm going to multiply this one by 10, 10A, 10B. It's 390. And I'm just going to subtract. So I get 10B is equal to 130. Or B is equal to 13. 13 bills for that matter. Ta-da! Okay. So that should be that for that one. Okay. That should be that for that one. It's the same. Two equations and two unknown systems. We apply that one for the early ones, and we're going to apply that for this ones. Okay. So I guess that's that. No, I'm sorry for keeping you guys late. I'm sorry for ending up a bit late. It's 11:20. We're supposed to 1:20 Hong Kong time, and we were supposed to end at 1:15. But yeah, I hope that's okay for you guys. Okay, and I guess that would be that one. Okay, so that's all of our 30 problems. Does anyone have any questions, clarifications, any further concerns? Do you have any? Do you have any more? Do you have any more? Any more questions or concerns? Have any? I think that's that, no? That's that for our lecture series on our 30 item mock exam. I don't think we have any more questions or yeah, something. None. Okay. So if ever you can contact me here, if ever you have any further questions or clarifications, I'll leave it here. So if you have any concerns that were unanswered, I'll leave it here. Okay. So I'll leave it as that. Okay. So no questions or no clarifications. Oh yeah, number 8. Okay, 8, right? We formed difference of two squares here, right? We formed difference of two squares here. Okay. So it looked like this. I lift them up one side and the other one the other side. It is a bit easier that way. That way I won't be a bit confused. So I'm going to add 4. So both sides will be perfect squares, right? And both are perfect squares, right? I form both as perfect squares there. No? X minus 3 squared and y minus 2 squared. But there are unlimited possible solutions for that. This is a solution. You try to substitute that, you'll get an answer. This is a solution. If you try to substitute that, it's correct. This is a solution. You substitute that one, it's correct. And you substitute this one, it should be correct. So what does that imply? What does that imply? It implies that almost every number that you can use an infinite number of solutions there. It didn't even say integer though. No, it didn't even say integer. So it could be anything. It could be a radical, it could be a fraction. No end to that one. So in a sense, we have almost a lot of different solutions and an infinite more that are possible for this form here, for this form, right? Yeah, as an activity, you can try this one here. That one also, and that one also. They actually all work. They actually all work. I'm really not sure. I'm really not sure. But you can like aim for more than half. That would be good. If you can get more than half, that's an assured good. Okay, so aim for more than half. That's what I think. I'm not really sure on the specifics, but more than half will assure you as well. Okay, so I guess that's that. So there are an infinite number of solutions, so we're gonna write it here. Anyways, I think we're at a loss of time. So any further questions, I'll entertain you here. Wait a bit, I'll leave it back again here. Okay, I'll entertain you here. Okay, so I guess that's that one. Any more queries, short queries? Okay, I'll entertain you lang here. If you have any following or if you want to follow up with that one, I'll entertain you here. Okay, so I guess that's that one for today. Thank you for being with me, Secondary 3. That concludes this lecture series. And good luck on your future endeavors. All right. So thank you and good luck next week. Okay. I'll see you guys next time. See you.
Good afternoon. 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 Good afternoon, Coach Ron. Sasabi lang.
उससे कहो ये ले लेना छोड़
Làm sao rồi?
Iwan. I think we can leave now. Leave. Hello?
Ủa giờ thoát hay giờ ngồi ở đây trời? Bye, thoát ra đây, bye bye.
In the meeting.
Goodbye. Hello. mag-join na ako.
Anong oras mo sila mo?
If you don't know.
Grade 4. May tanong ko kung saan ako Hello.